I'd like to start by removing the head from the pump. One of the first things I'd like to point out is that in the head you see a crescent, which is true of all internal gear pumps, but you do not see an idler pin pressed into it, so you start to notice some difference in the technology right away. Next pieces to remove are the idler gear and the eccentric spindle. This is the patented stationary eccentric spindle we talked about. We talked about the key feature of between the bearing support system. This spindle allows us to remove the overhung load or cantilevered load from the pump. How that would work for the idler gear is I mount the idler gear on the spindle. The spindle is now supported in the head and at the crescent area. When I bring these two together, the idler gear is now free to rotate on that spindle, and yet as hydraulic forces develop, is now supported on two sides rather than just one. This increases the life of the idler gear and its bushing. Continue by disassembling the pump. I take the casing off. Casings are available with a variety of pipe connections, either threaded or flanged. We also have the option of side-ported casings. The casings can be rotated to accommodate your current piping arrangement. The next piece is the rotor assembly. Another key feature we talked about was the fact that the EnviroGear is based around a one fluid chamber design, and you can see that with the rotor assembly here. On a traditional pump, you'd have a rotor gear and idler in the hydraulic chamber, and you'd have an inner set of magnets in a magnetic coupling chamber, some kind of an adapter plate or bracket which essentially divides those two chambers. Within the EnviroGear pump, we took the magnets from the rear chamber and mounted them right on the back of the rotor, essentially taking a two fluid chamber system and creating one. You can see that by looking at the containment can where the rotor assembly rides. It seals up against an O-ring on the casing. When the pump is bolted together, the flange of that containment can seals up against that O-ring, and now looking through the front of the casing, you can see that there's no restriction of flow between the casing and the containment can. Therefore, more flow, more cooling, a far simpler design. Discussing further the feature of the between the bearing support system, you see that back inside the containment can is the rear support for the spindle. The spindle is then again supported here in the crescent and back up in the head. So now when it's fully assembled, we have 2 points of support for the rotor gear, 2 points of support for the idler gear, greatly reducing the deflection within the pump and thereby reducing the premature wear that can occur. In spite of its innovative features, the EnviroGear is based around a very fundamental pumping principle, and that is of an internal gear pump. We have a rotor gear which rides on the ID of the casing, and an idler gear which rides internal to that rotor. As the rotor turns, as the gears turn within the pump, liquid moves through the pump, and as the gears mesh near the discharge port, liquid is forced out. That's the same pumping principle that's been used in internal gear pumps for 100 years now. The last component of the pump would be the outer mag drive housing. There's an outer set of magnets, which are then supported by 2 greased and sealed for life bearings connected to the drive shaft. Drive shaft can then be connected to a gearbox or a motor. We also make C-face adapters, which allow you to close couple motors or gearboxes directly to the pump. You can see here that simple design based around 7 primary components: outer mag drive assembly, containment can, rotor assembly, the casing, the eccentric spindle, the idler gear, and the head. So let's go ahead and start reassembling this pump. Just to have a quick review of magnetic coupling technology, outer set of magnets hooked up to the motor rotate. They rotate on the outside of the containment can. When I bring the inner magnets mounted on the rotor assembly in proximity, I form a magnetic coupling. So now when I hit the motor, my rotor turns and you have no shaft penetration. There's no rotating shaft within the pump. And now bring my casing in place, bolt it together. The O-ring on the casing seals against the flange on the containment can to make a tight seal. I then put my idler gear on the spindle. The spindle is then locked in and supported by the head. And then mount those together and we can finish bolting this up. It's as simple as that. One of the last key features we talked about was dimensional interchangeability. This pump is designed to be dimensionally and hydraulically interchangeable with leading heavy-duty industrial gear pumps. That means dimensions such as the center line of the flange to the end of the shaft are going to match. The dimensions between the faces of the flange will match. The footprint of the pump will match up, so you can bolt it down to your existing base plate, hook it up to your existing piping, and you're ready to go.